Now we move to problem 2.a. Again, we have to draw the network diagram for this case, but the difference is on problem 1, the info about normal time is given, while in the second problem, we are given the optimistic time, symbolized with A, most likely time, symbolized with M, and then pessimistic time, symbolized with B. Based on the data given, we have to find the normal time using this formula. A plus 4M plus B divided by 6. And we have to calculate for each activity. So it's better for us to make a new table like this and compute the normal time using the mentioned formula. For example, normal time for activity A is the optimistic time of activity A, 1 week, plus most likely time of activity A, which is 2 weeks, multiplied by 4, and then plus the pessimistic time of activity A, 3 weeks. Then divide them with 6, and it is equal to 2 weeks. So the normal time for activity A using this formula is 2 weeks. Okay, and then we calculate the normal time for the rest of the activities using this formula as well. After that, we have to find the variance for each activity too. We get it by using this formula for variance. Okay, the formula is for variance B minus A divided by 6, and then we squared it. For example, the variance of activity A is its pessimistic time, which is 3 weeks, minus its optimistic time, 1 week, and then divided by 6. Then we squared it. The total is 0.11. Then we place it to the table. Okay, and then we calculate the variance for all the other activities using the same formula. Then just put the result to the table. After we got the normal time and variance, now we can draw the network diagram using the info on the table that we made before. Okay, but here we have to draw the start first. I'm sorry, at problem 1 I didn't draw this first before the first activity, but here I try to draw the start, and then we first draw the activity A. Okay, it doesn't have predecessor activity, so we just put it after start, and so does for activity B. It doesn't have predecessor activity as well, and so does activity C. So we put A, B, and C after start, and they're not connected. Next, look at activity E and D. They have the same predecessor activity, which is activity A. So activity A has 2 branches, followed by activity D and E. So we connect activity A to activity D and activity A to activity E. After that, activity F. Its predecessor is activity B, so we put activity F after activity B. Next, activity G. It has activity C as its predecessor, so we put activity G after activity C. And don't forget to connect B to F and C to G. Next, we have activity H. It has 2 predecessors, activity D and E, so we put activity H in front of D and E. And then connect activity D to H and E to H. Next, activity I. It has 3 predecessors, activity D, E, and F. We could just draw it here, below H. And then connect D to I, E to I, then F to I. And then activity J, it has 4 predecessors, activity D, E, F, and G. Okay, just draw it below I and connect H predecessor to J. Last one, activity K. Its predecessors are H, I, and J. So draw K here in front of H, I, and J, and then connect them. Now we're done mapping each activity. Next, we have to write each activity time. Just place the normal time that we have calculated before, and the number is on the table that we made before, on each table for each activity. And sorry, I forgot to connect the start to each first activity. After that, count the earliest start and earliest finish starting from activity A to activity K. Don't forget, for ES and EF we do it forward pass, okay, from the beginning to the end of the activity. The earliest start for activity A is 0, okay, and the earliest finish is 0 plus the activity time, which is 2 weeks. So the earliest finish for activity A is 2 weeks. Earliest start for activity B and C is also 0, okay, and then for each earliest finish for B and C, just add the earliest start with the activity time. Move to activity D. Its earliest start is 2 weeks, which is the earliest finish of activity A, and the earliest finish is 2 weeks plus 11, 13. And then for activity E, its earliest start is 2 weeks, and earliest finish is 2 plus 8. Repeat the same step for activity F and G because it has the same pattern, you know. Next, activity H, we get the earliest start by picking the longest or the maximum earliest finish of D and E, since they are the predecessors, okay? And we pick 13. So the earliest finish is 13 plus 3.5. For activity I, we get the earliest start by choosing the maximum earliest finish of its predecessors, which is activity D, E, and F. Then we choose 20, so the earliest finish is 24. For activity J's earliest start, we have to choose between activity D, E, F, and G. And the maximum is 20, so the earliest finish of activity J is 26. Last one, activity K, the earliest start equals to 26. Okay, the earliest finish of activity J, and then its earliest finish is 28. We're done with the earliest start and earliest finish. Now we're calculating for latest finish and latest start. Starting from K, since it is the final activity, so its latest finish equals to its earliest finish, which is 28. So then the latest start is 28 minus 2. Okay, then just repeat the same steps that we did on problem 1 for the rest of the activities here. Keep in mind, to find the latest finish, if there are any branches, choose the minimum previous latest start. To find the shortest duration, we have to find the select time first for each activity. Just like what we did in problem 1, we can find the select time by reducing the latest start by the earliest start, or latest finish minus earliest finish. Okay, then we compute for each activity. Okay, for example, for activity A, the select time is 7 minus 0. And then for B, 0 minus 0 or 5 minus 5, and so on and so on. Okay, we do the same for all the activities. Okay, now we have the select time for each activity, then we have to define the critical path. We have to choose any activities which have 0 days for its select time. So based on that, we choose activity B, and then activity F, followed by activity J, and then the last one is activity K. So the critical path is from activity B to F to J and to K. Now we compute the total activity time for the critical path. B 5 weeks, and then F takes 15 weeks, J is 6 weeks, and then K 2 weeks. Okay, then we get 28 weeks for this project to complete with activities which cannot be delayed are B, F, J, and K. Now problem 2.C. Okay, to know whether the judgment is acceptable or not, we have to find the standard deviation first. And to get the standard deviation, we have to sum all of the variances of activities on critical path. So the formula goes like this. Then input the number of each variance of the activities on the critical path. Okay, the number, we could get it from the table that we met before. And the total for all variances is 7.78. That's just the variances, but we have to find the standard deviation. So just square root the number. And finally, we get 2.79 for the standard deviation. So here we want to find the due date for this project. And we could get it from adding the expected due date. Okay, we're adding the expected due date with the z-value times the variance we just calculated above. We already have the expected due date, which is 28 weeks. Okay, we get the 28 weeks from the earliest finish or the latest finish of the final activity at our network diagram, which is activity K. Here we get the z-value by reducing 100% by the confidence level, which is 95%. Then we get 5% as our alpha, or 0.05, and it's stated on the problem that the z-value for 0.05 is 1.645. Okay, then the z-value multiplied by the standard deviation above. And finally, from the calculation, we have 32.59 weeks, which is, its number is longer than the expected. Okay, 30 weeks stated on the problem. So the statement that it could be complete within 30 days, 30 weeks, is not acceptable. Now, problem 2.d. What's the probability that the mill will be fined $300,000? Okay, so how do we find the probability is by finding the z first. But this one, it's not like the previous z. Here we find it by reducing the 30 weeks with 28 weeks and divide it with the variance, or 2.79 weeks. And okay, it's the variance that we calculated before, and the result is 0.72. Then we look at the table on Appendix 1 in your book. The table looks like this. Okay, and then here on the table we look for this number, 0.72. Okay, on the vertical line we look for the first number behind the decimal point, which is 0.7. And then for the horizontal line, we look for the second number behind the decimal point, which is 0.02. Okay, then we find where they are crossing, and it's on 0.76424. Okay, so we got from the table that they are crossing at number 0.76424, or it's equals to 76.424%. Then we reduce 100% by that number to get the probability. Okay, so the probability is 100% minus 76.424% equals to 23.576%. So that's the probability of the mill will be fined $300,000.